Hello students, welcome to my lecture on operating system. Today I will discuss threads. I am Shabani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. After going through this lecture, you will be able to understand what is a thread, what is the concept of multi-thread, and how thread differs from the process. Now, before that, I will discuss some basic concept that why we need the thread. So, now first you have to understand what is thread. So, thread is basically called the lightweight process. Fine. So, lightweight process means a process has, what is a process? Process is a program. Along with that, it has other set of resources. But in case of thread, it is similar to the process, but as the process has a separate set of resources, a thread doesn't have its own set of resources. It shares the resources of the process. So that means a thread is basically associated with the process. Fine. So if a process, if we create a process and consider there is a process like a process P, fine. So this is our process. Now this process has a set of instructions and some resources. So this is a set of instruction. Let us say this is a set of instruction and there are some set of resources R. Fine. Now, this process cannot execute by itself. To execute the process, we need a thread that is called the main thread. So, while a process is executed by itself, that means a thread is running on behalf of the process. And in that case, the thread uses the entire resources of the process. Fine. But why the thread is called the lightweight process? The thread is called the lightweight process because for a particular process, if it creates multiple threads, so consider for the process P, it creates multiple threads. One is called thread 1, another is thread 2. So both thread 1 and thread 2 will use the common set of instruction and the common set of resources. Fine. So a set of resources which is assigned, which is allocated for the process P, that set of resources will be used, will be shared by both the thread T1 and T2 created by the same process P. But if we create a child process, so consider P is a process and we create a child process C. So while we will create the child process C, after creation of the child process C, the C will have its own set of instruction and own set of resources. So the child process will not share any resources or instruction from the parent process. So in this way, we can differentiate between the child process and the thread. So while we are creating the thread, we are not bothered about to assign some additional resources, some extra resources, separate set of resources to them. So that is the advantage of the thread, and the thread can perform same task as it is performed by the child process. So that's why the thread is quite faster and easy to implement compared to the child process. Fine. Now here you can see there is an important thing is there that thread runs within the application. Within the application means what? Within the application means when a process is created, the thread runs within that process. It is not outside of the process. It is not the part outside or any element which is outsider of the process. A thread is a part of the process. That why it is a part of the process? Because it is sharing the same set of instruction and same set of resources. Fine. Now the next question is why we should go for multiple threading. The multiple thread is mainly used for the server application. So we will discuss in the next slide how the multiple threads will be useful for the server process. But here you can see another important point, that multiple tasks with the application can be performed simultaneously with the help of the multiple thread. Suppose in a program P, you have this, under this program P, you have two set of operation. One set of operation is defined inside the function f1, and another set of function operations are defined inside the function f2. Now f1 and f2 are not overlapping function. Overlapping function means the execution of the f1 is not dependent on the execution of f2. Fine. So in this case, what will happen? The thread. So if I go for a single thread, single execution, so all the process. So suppose the organization of the process is like that. This is a main. Inside the main, there is a function f1 and there is another function f2. They are calling one after another. So this is a sequential execution. But if we go for the multi-threaded programming, so in that case, and if f1 and f2 both are not dependent on each other, so in that case, what we can do, the process can create two threads. One thread will execute the function f1 and another thread will execute the function f2. So that means suppose thread t1 will execute the function f1 and thread t2 will execute the function f2. So as two threads will execute the same process, the execution time will increase. So that's why we will go for the multi-threaded environment. That means multiple tasks inside an application can be implemented with the help of the thread. Fine. So here is one example is given. So consider you have an application where there are four operations, four functions are there. First function is the update display. Second function is fetch data. Third function is spelling checking. Fourth function is answer or network request. So here those four actions are four independent actions. They are not dependent on each other. So maybe in any moment all the actions needs to be executed simultaneously. So in that case, if that application provides different threads, that means under the thread 1 is responsible for executing this part, thread 2 will be responsible for executing this part, thread 3 will be responsible for executing this part, and thread 4 will be responsible for executing this part. So what will happen? All the parts, all the functions can be executed at the same time. Fine. So that you can see in the next slide. You can clearly understand why all the application we need to execute all the application simultaneously. Fine. So here you can see a multi-threaded server architecture. Fine. So in this architecture there is a client and there is a thread. So consider, I'm going another example. Consider this server. This is a Gmail server. Fine, the Gmail server, most commonly mail server, which is Gmail, and there is a client. Now, when the client sitting on the system wants to access the mail, definitely that means wants to perform the login operation, it open the Gmail page, supply the user ID and password, and it send the request. So consider the user 1 at the client side 1. So this is client side 1. User 1 at the client side 1 open the page of Gmail and supply the user ID password and press the login button. So when it will press the login button, the request will go to the server. Fine. Now, at the same time, maybe there is another, in another client, there is another client, let us say it is client 2, and in the client to another user U2, that user already opened the page and it wants to perform some operation like compose mail or send mail, or it wants to check the mail. So again, it is sending a request to the server to perform some other operation. Fine. So you can see that there is a single Gmail server, there is a single application which can perform, which can help the user to log in, which can help the user to access the mail, which will help the user to fetch the data, delete the mail, send a mail. So all the applications, all the functionalities present inside the server. Now, if more than one client wants to perform the same set of operation, so consider there is another client which is client 3, and user 3 on this machine wants to perform another operation, like it wants to perform the login operation. So what are the operations they were performing? User 1 is performing the login operation, user 3 is also performing the login operation, but user 2 wants to compose some mail, or let us say it wants to send a mail. Fine. Send operation. So you can see inside the server, an application, a function is written to perform the login operation. Another function is written to send the mail. Now, when both the clients wants to perform the login operation, they are calling a single function. But single function at a time can provide the service to a single user. So what happened over here in this case, in this particular case, for that login operation, this application, login application creates multiple threads depending on the number of users. Fine. So as there is 2 users who want to perform the login operation, so in this case, for this login operation, 2 threads are created. One is T1, another is T2, for example, inside the server. Now thread 1 will perform the same login operation. Thread 2 will also perform the same login operation, but thread 1 is responsible to handle the request sent by the user 1 on the client machine, and thread 2 is responsible to handle the request sent by the user 3 on this site, client 3 site, on the site client 3. So here you can see that one application can provide service to the multiple user with the help of the thread. Fine. And to create the 2 threads, the system doesn't require much more resources. The thread T1 and T2 both will access the same set of resources which are assigned to the login process. Okay. Now, another instance, another example, you can say that in this server there is another operation which is another functions or process, you can say, which is send. Fine. Now, when the client user 2 from the client side to send the request to send an email or send any mail, in that case, this send process initiate a thread and that thread will handle the U2. That means here inside a single server for single mail operation, so there is one application which is called the mailing service. There is a login operation, login process, send process. So under this mailing service, the login process can at a time serve request for 2 users, that is by the help of the thread 1 and thread 2. Again, the send process can handle the request of user 2 by creating a thread. Fine. So in this way, multiple thread can help us to serve the request towards the user. Fine. So that is the advantage of the multi-threaded program. Fine. Now we will discuss the benefits of thread. That means how the threads are useful for us. Now, the benefits of the threads is mainly described with the help of 4 points. Those are the responsiveness, resource sharing, economy, and scalability. Fine. Now, what is responsiveness? So, you know that in multi-threading is an interactive application, and it can allow a program to continue running even if part of its blocks or if it is performing some another operation. Fine. So actually what will happen, so a program has multiple, while we will write a big program, in while we want to write the application is divided into several parts, several functions. So it may happen that one function can take long time compared to the other functions. So as I discussed earlier, consider this program like main. There is two functions, one is f1 and another is f2. Fine. Now and this function is present in the server side. Now from the client side, client 1 wants to access, from the client side 1, the user wants to access the function f1. From the client side 2, the user wants to access the function f2. Okay. Now what will happen? Let us say that if there is a single thread concept, that means the execution is sequential. After F1, the F2 will be executed. If the situation is like that, then client 1 will send the request to the server. Server will first complete the request. That means it will be busy to perform the action of F1, perform the execution of F1. And once the execution of F1 will be completed, then the server can handle the request sent by the client 2, that is F2, execution of F2. So in this case, if F1 takes long time for the execution, then F2 has to wait. Fine. So what will happen over here? In case of multi-threaded programming, what the server will do, so what I discussed so far, that is for the single thread. But if I go for the multi-threaded programming, in that case, one thread is assigned to the function f1 and another thread will be assigned to the function f2. So when the client 1 will send the request, then the f1 will be executed, and at the same time as if the client 2 send the request for f2, the f2 will be executed with the help of the another thread. Fine. So that means two threads can execute parallelly, and though the function f1 will take longer time, still the client 2 and client 1 both can get their response at the same time. That means the responsiveness will increase. Okay. Now there is another important benefit of thread, that is called the resource sharing. So as you know that while we will create the thread doesn't need a separate set of resources. So the resources which will be assigned to this program, so those set of resources will be used by both thread 1 and thread 2. That means thread 1 which will execute the function f1, and thread 2 which will execute the function f2. That means both the thread can share a common set of resources. Fine. Now as both the threads will share a common set of resources, that means we don't need some additional resource. That means the cost to assign the resources to the thread will decrease. So that's why the thread program with the multi-threaded program is cheaper compared to the multiple processor, creation of the multiple process. Fine. So multi-threading is always cheaper. That means it is very, if I consider the economy, it is always very cheaper, and it can be easily executed with low cost. Fine. Now the next one is the scalability. That is also very important features of the thread. As the thread doesn't require so much resources, so and it can, so we can increase the number of threads as many as we require. Fine. So as per our requirement, we can increase the number of threads easily. Also, as per our requirement, we can also decrease the number of threads. So that means the scalability part of the thread is very easy. Fine. Now, before going to the details of thread, that means the different types of thread, I will discuss another important topic, which is called the concurrency and parallelism. Now, what is the difference between concurrency and parallelism? Concurrency means that we always say that two processes are executing concurrently. That is, process P1 and process P2, both are executing concurrently. Both are executing concurrently means both the processes are executing on the overlapping time slot. It doesn't indicate that the process P1 and process P2 will execute parallelly, that means at the same time. Fine. But in case of parallelism, both the process P1 and P2 can execute at the same time, at the same slot. Fine. So concurrent execution is applicable for the single core system, while the parallelism is applicable for multi-core system. So here you can see that as example, where the time slot is divided into some, the entire time, processing time is divided into some slots like T1, T2, T3, T4. Now what happened if P1 and P2 are executing concurrently, then P1 will execute at the time slot T1, P2 can execute at the time slot T2, then P1, then P2, P1, so like this one, fine. So they are executing with overlapping time slot, so that after T4, we will get both the output for P1 and P2, fine. But in case of, so here you can observe that P1 and P2 are not executing at the same time, fine. But in case of parallelism or for the multi-core system, what happened? Core 1 is totally responsible for execution of P1 and core 2 is totally responsible for execution of P2. Fine. That means at the same time, both the processes P1 and P2 will be executed by the system. And how is it possible for the multi-core system? You can observe one important thing, that in this under this one time slot, this time slot is basically divided into two parts. So one time slot is basically divided into two parts. First part is for the instruction fetching. Instruction fetching. And second part is for the execution. Fine. That means this entire time slot is not used for the execution. So under a single time slot, some portion is used for the instruction fetching and the another part is used for the execution purpose. Fine. So what happened in case of multi-core system? So how the T1 and T2 both can run in the same time? The both can run in the same time because, so if you can divide it like this one, the first part is the instruction fetching first. So this is the instruction IF. I am writing IF for instruction fetching. And second part is for the instruction execution. So I will write IE for that. Right? The second part is for instruction execution. Okay. Now, in the next, for the core 2, this is a overlapping. That means this one is for instruction execution and this one is for instruction fetching. Okay. So what happened? Before this slot, there may be another slot like this one. That slot will be used for instruction fetching. So here you can see that while the instruction execution operation for the process P2 will be performed, at the same time the instruction fetching operation of the process P1 can be performed for the using the multi-core system. Fine. In a single processor multi-core system. So in this way we can implement the parallelism with the help of multi-threading. Fine. Now here you can see a diagram, single thread process versus multiple thread process. So from this diagram, it will be very clear, it is easy to understand why we can say that thread is a lightweight process. So this is the entire process. So let us say this is the process P1. Fine. It is the process. This is for the process P1 and this is for the process P2. Fine. So if the process P1 is executed by the single thread, that means this one thread will execute the code section, data section, file, register and stack. And let us say the process P1 has the function set like F1, F2, so on. So the thread, this one single thread will first execute the F1 with the help of all these resources. Then after completion of the F1, it will execute F2 with the help of all these resources. Fine. Let us say there is another function F3. So F3 will also be executed with the help of all these resources, but one after another. But in case of multi-threading process, so let us say P2 is a multi-threading process where there is the same set of function F1, F2 and F3. Fine. Now if we create 3 threads for the same single process P2, so 3 threads will share the common data, code and files. And what is the additional resources? The additional resources they required is the register and stack. So only a separate set of registers and stack is required for the thread for the execution. The code, data, files will not be repeated for the different threads. All the threads will share the common code, data and files. Only while we will create the thread, we need to assign a separate set of register and stack for the storing of the intermediate data. So what happened over here? So as for this process, for the process P2, as it is executed in the multi-threaded environment, so 3 threads are created. So this first thread is responsible for executing the function F1. Second thread is responsible for executing the function F2, and the third thread is responsible for executing the function F3. So all 3 threads can execute F1, F2, F3 parallelly. That means the overall execution time will decrease. So from this example, you can clearly understand that while the multi-threaded environment is more faster and why the responsiveness is so high. Fine. But if you go for the multi-process, that means but for the process P2, instead of creating single process P2 with 3 functions, if you create a process P21 with the code of F1, P22 with the code of F2, and P23 with the code of F3. So in that case, what will happen? You need to create, for the process P21, you need a code, data, files and register stack. For P22, you need code, data, files and register and stack. For P23, you also need a separate set of code, data, files and register stack. So P21, P22 and P23 will not share the common code, data and files. But instead of creating 3 different processes, if we create a single process with multiple threads, we need only one set of code, data and file, and only we need a separate set of register and stack for the execution. So that is the advantage of thread over the process. Now I will discuss the different types of threading model. So the threading models can be divided into 3 categories. One is many to one, one to one and many to many. Fine. Now, okay, another important thing which I should mention, that before going to the details of the threading model, the entire thread for the system, operating system, can be divided into two classes. Fine. First one is the user level thread, and second one is called the kernel level thread. Fine. So threads can be divided into two categories. One is the user level thread and second one is the kernel level thread. Now, what is the user level thread? The thread which is responsible for handling the user level application, that means the application program, those threads are called the user level thread. On the other side, the threads which is responsible for handling the functions of the kernel level, that means the functions of the operating systems, then those threads are called the kernel level thread. That means if we want to execute any process, so let us say we want to execute the process P, where we need to perform a set of operation F1 and F2 set of function. F1 needs to perform some input operation, make it specific, some input operation, and F2 needs to perform some output operation. Fine. So what happened here, this process P with all this F1 and F2, this is called the application level program. Fine. So that means if I want to execute F1 and F2 parallelly, then we need to create two threads. One is thread T1 for function F1 and we need to create thread T2 for the function F2. So these thread T1 and T2 are called user level thread. Fine. Now this function F1 needs to perform the input operation and F2 needs to perform the output operation. So as you know that input to perform the input operation or the output operation, we need to call the services of WES. And which services we need to invoke? We need to invoke the IO services. So service is nothing but a program, but this is a program on the kernel side or operating system. Fine. So what happened when the function F1, when the thread T1 needs to execute the input operation, it try to interact, try to fetch the IO services, try to take the help of the IO services. Now this IO services is a service which will create a thread T, let us give some another name, suppose thread T3, which will provide the input service. The same IO service will create another thread T4 which will provide the output service. Fine. Now this T1 will take the help, that means perform the input operation we by the help of the thread T3 which is called the kernel level thread. That means the user level thread needs to interact with the kernel level thread. So T3, the kernel level thread T3, which provides the IO service of the operating system, can interact with T1. Similarly, the thread T2, which is in the user level, which is a user level thread, will interact with the thread T4 to get the output service. Fine. So here you can see that though the thread is divided into user level thread and kernel level thread, two different categories, but the user level thread and kernel level thread needs to interact with each other. Fine. So based on the interaction, how the user level thread will interact with the kernel level thread, all the threads are divided into three categories. One is called the many-to-one, one-to-one, and many-to-many. Okay. So now next we will discuss the different types of thread. What do you mean by one-to-one and what many-to-one and many-to-many? Okay. Now first we will discuss the service which is called the many-to-one. Many-to-one means many kernel level thread will interact with the single, many user level thread will interact with the single kernel level thread. Fine. So here you can see that those are the user level thread, and that is a thread. This is a kernel level thread. So all the threads are interacting with the kernel level thread. Now what is the disadvantage of this particular threading system? The disadvantage is that the services provided, that means there is a single thread. This thread provides service to the thread 1, thread 2, thread 3 and thread 4. Now the services will be provided one after another. They may run in sequentially. Fine. So in that case, what will happen? First, the thread 1, suppose that this service of the thread 1 will be this kernel level thread, let us name it K. So K will provide service to 1. After providing the service to the thread 1, K will provide the same service to the thread 2. Now due to some writing error, due to some syntactical error, due to some logical error, maybe the execution of the 2 cannot be stopped. So some blocking will occur for this case. So as the execution of the thread 2 is not completed due to some error, then this kernel level thread K cannot provide services to thread 3 and thread 4. So that is the disadvantage for one-to-many model. I mean many-to-one model. So if many user level thread is getting the service from a single kernel level thread, in that case the blocking may occur, and which can stop the execution of the other threads. Fine. Now the next model is one-to-one model. Now in that case, one-to-one model, you can see that one user level thread is associated with one kernel level thread. That means for each user level thread, a kernel will create another thread dedicated to that. So here the execution is faster, but the problem is many threads you need to create at the kernel level, and that's why the cost will increase. Fine. Now the next is called the many-to-many. This is the last model, which is called the many-to-many thread. Now in that case, in the case of many-to-many threads, there are many kernel user level thread and many kernel level thread. Fine. Now what will happen? Suppose there are in this example, you can see that there are m number of user level thread and n number of kernel level thread, and here m is greater than n. So what happened here? One thread can get the service from 2 threads, or one user level thread can get the services from 2 kernel level thread. That is one possibility. Another possibility is 2 kernel level threads, I mean one kernel level thread can provide service to the 2 user level thread. Fine. So both the cases is possible over here, but here what is happened, we try to make it cost effective. Fine. So in that case, in many-to-many model, there are many user level threads and many kernel level threads, and as per the requirement, one kernel level thread can provide the service to many user level thread, and one user level thread can take the services from many kernel level thread. So this model is called the many-to-many model. Fine. Now there is another example, the 2-level of model, which I discussed, the many-to-many model and one-to-one model. Fine. And those are the different systems. They will use those setup, that concept to implement the operating system. Now next I will discuss another important topic, which is called the difference between the thread and process. Fine. So already I told many difference between the thread and process. So still I'm just writing it. This is process and thread. Fine. So what is the first difference? First difference is in terms of the context switching. So I think you can remember what is context switching. Fine. In terms of the context switching, process need more time, whereas thread needs less time. Fine. So you can see that to perform the context switching operation, if we create the process, if the context switching will be performed between two processes, that means there is a process P1 and process P2, and the context switching needs to be performed between these two processes, then the time required is comparatively greater than the times required to context switching between two threads, which is called the thread 1 and thread 2. So if I need to perform the context switching between these two threads, then we need less time. Fine. Another thing is memory sharing. As you can see that process cannot share memory. That means if there are two processes P1 and P2, they cannot share the common memory. They have a separate set of memory. So sharing is not possible. Fine. So it is memory sharing. We can write not possible. But here, in case of thread, they can, at least they always share the resources. That means for the thread, memory sharing is possible. Fine. That is another example. Third one is blocking. So in case of process, single process, if the process gets stuck in middle of the execution, this entire execution of the entire process will be hampered. Fine. But so execution will be, so that means the execution of process is not possible if it is blocked. If it is blocked in between, that means during the execution, but in case of thread, it is not blocked. If one thread is blocked, but another thread can complete their execution. That means the partial execution of the process is possible. Now, another important thing is that, like memory sharing, the process also can share the data and instruction. That means memory, data, instruction can be shared by the process, cannot be shared by the processes, but it can be shared by the thread. Another important topic another important difference is there in terms of the creation time. Fine. So let us write it over here. This creation time. Process need more time to create, but thread needs less time to create. Fine. And termination, definitely like the creation time, for the termination also the process needs more time to terminate and thread needs less time to terminate. Fine. So that is the major differences. Those are the major differences between threads and processes. So context switch, in terms of the context switching, process needs more time, thread needs less time. In terms of the memory data and instruction sharing, sharing is not possible for the process, but sharing is possible for the thread. If the process is blocked in between, the execution of the entire process gets hampered, it's stuck. But in case of thread, if one thread is blocked, but another thread can complete their execution. In terms of the creation and termination of the process needs more time to create and terminate, but thread needs less time to create or terminate. Okay, so that is all about the threads.